Find the rank of a set C to be the least such alpha such that C is a subset of V sub alpha. Compute the rank of the set containing the empty set, and also compute the rank of the set containing the empty set, the set containing the empty set, and the set containing the empty set, and the set containing the empty set. That was horrible. Okay, so this is not too difficult of a question. It's just a bit tedious and cumbersome. But let's get through it. We'll have to go through all these exercises eventually. Might as well get it out of the way right now. So recall that V sub alpha is defined as, or rather, it's defined inductively via this relation. So V sub alpha plus 1 is equal to V sub alpha union the power set of V sub alpha, where our initial state, our base case, whatever you want to call it, V sub 0 is equal to A, the set of all atoms. Cool. All right, so yeah, so now, oh, right. And atoms, if you remember, are all elements that are not sets. Okay, so if something is not a set, then it goes in V sub 0, and otherwise you just start constructing sets by taking repeated power set operations. Okay, cool, fantastic. Now, what do we do now? Now we have to show that, or rather we have to find the minimum alpha, the minimum number such that this set is a subset of this V sub alpha, and same thing for this set. Okay, so let's just split this up into two cases. So one, we're going to work through this one first. So what is the minimum C such that it is a subset of V sub alpha? There might be a smarter way of doing this, but I want to be thorough and I don't want to leave any stones unturned. I try to rely on intuition as little as possible when making these videos. So we're just going to incrementally go from 0 all the way to infinity if we must, until we find the minimum alpha such that this is a subset of V sub alpha. Okay, so let's start at the beginning. So is this set, and you know what? I am going to call this A. Just to keep my sanity, I'm going to call this set A for now, so I don't have to rewrite it. So the question is A a subset of V0? Well, V0 only, or rather, one way, sorry, I keep getting stuck in my words. The question we're asking is, in here, is if A is a subset of V0, then an equivalent question to ask is the empty set in V0, right? Because if the empty set is in V0, then every element within A is going to be within V0, and thus A will be a subset of V0. Now, you'll notice that this is not just a set, but a non-empty set, so it clearly cannot be in the set of all atoms, which are defined to be not sets. So this is not true. And just for bookkeeping, let's do this. All right. And now let's start with V1. So recall that V1 is going to be equal to V0 union with the power set of V0. And just as a side note, is that since the power set of V0 is equal to the set of all x such that x is a subset of V0, then the empty set has to be in the power set of V0. So that's how we get sets going in this V construction. Why? Because the empty set is a subset of all sets. This is not rigorous notation, but it's just a fact because the empty set is a set, starting off from there, and every element inside the empty set, meaning nothing, is also an element of every other set. It's what is called a vacuous truth in logic or in math in general. It just means that it's absurdly true. But if that didn't make too much sense, that's okay. Just take this as a fact for now, and eventually we'll get to vacuity, or if you've taken a class in mathematical logic, you'll know what I'm talking about. Anywho, I'll stop rambling. Okay, so our question now is A a subset of V1? Meaning that is this set in V0, or is this set in the power set of V0? So we can rule this option out just right off the bat because in V0 there's no sets. So that's good. That simplifies our thinking for now. And now the question is this set in the power set of V0? And recall, well, I guess we just wrote it out. So the power set of V0 is x such that x is a subset of V0. So for this to be in the power set of V0, then we would need this to be a subset of V0. But of course, this doesn't work because this itself would imply that the empty set is in V0, which we just showed is not true because the empty set is a set. So, all that to say that A is not a subset of V1. Cool. I'm just gonna cross this one out. But what about V2? So V2 is, recall V1 union the power set of V1. So is A a subset of V2? Equivalently, we're asking, is the set containing the empty set in either V1 or is this set in the power set of V1? Now, we can rule this one out by our previous reasoning, right? Because if this were in V1, then it would have to be either in the power set of V1, either in V0 or the power set of V0, which just doesn't work. So, now the question lies here. Is empty set, sorry, in the power set of V1? And for that, we have to ask, equivalently, is the empty set a subset of V1? Okay, now we're getting somewhere. So for the empty set to be in a subset of V1, we need every element in the empty set to either be, oh wait, I'm sorry. I just, okay, this is so dumb. I already explained this, but the empty set is a subset of all sets. So this is true, right? Okay, good. So if you want to, for all S, I'm just going to write it out here. For all S as an aside, just the fact that we're using of the empty set. Cool. All right, so indeed, A is a subset of V2. Thus, the rank of A, which is equal to this monstrosity, is 2. All right, phenomenal. So we got through this one. And now they're asking us to compute the rank of this set right here. I'm going to start it off in this new page. Now 2, and it is this here. This right? All right, that looks about right. Let's double check. I'm missing one parenthesis. Yeah, or one bracket. Okay, so let's just go through it. And we have to ask for any v sub alpha. We have to ask, oh, and also to simplify our lives, let's call it set B. Whether B is a subset of B alpha. So let's go through this procedure again. B naught. So V naught is equal to the set of all atoms. So just right off the bat, B is not a subset of V naught. So let's just cross this one off the list. V1, and just, you should on your own be probably thinking that this is not going to be any lower, or there's no reason why this would be lower rank than this set. But let's go through it. Okay, move this down. All right, so is B a subset of V1? Well, V1 is equal to V naught union the power set of V naught. And we know that for B to be the power set of, sorry, for B to be in V1, sorry, then for B to be a subset of V1, then this has to be in V1, this has to be in V1, and this has to be in V1. And I'm just going to use the ampersands because that is what Enderton uses for the logical AND operation. Okay, so what are we saying over here? We're claiming that for B to be a subset of V1, then either the empty set has to be in V1, sorry, that it must be simultaneously true that the empty set is in V1, that the set containing the empty set is in V1, and that the set containing the empty set and the set containing the empty set is in V1 as well. Now, we could go over our procedure again and just check these individually, but note that we already did this check in a way where we showed that specifically here is not in V1. We showed this, right? So already we know that one of these is not true. So this is not true. And thus we can just end early and say that B is not a subset of V1. And just, nice little red cross. So B2. On we go. Okay. So same deal. For B to be a subset of V2, then we can equivalently ask the question whether the empty set is in V2 and the set containing the empty set is in V2, and the set containing the empty set and set containing the empty set is in V2. Okay, so this, I'm gonna just step through these one by one really quick. So V2, because V2 is equal to V1 union the power set of V1, and power set of V1 is equal to the set of all subsets X such that X is a subset of V1. And for all S, the empty set is a subset of S. So the empty set is a subset of V1. So the empty set is in V1. And thus we are Gucci here. Okay, cool. Now, similarly, we already showed here that here, since we showed that this set is in the power set of V1, we equivalently showed that this set is a subset, sorry, that this set is a subset of V2. Or am I saying this right? Oh, no, 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 no. Okay. We said that this is true. Sorry, I promise this will get better as time goes along. So this corresponds to that. But I'll just step through it again because that must have been pretty confusing. Okay. V2 because what? Because V2 is equal to V1 union the power set of V1. Okay. Oh, what? And and my brain shuts off sometimes when I'm doing math. And okay, is this okay? I'm just gonna is in the power set of V1 because power set of V1 is equal to X such that X is a subset V1 and okay. Is a subset of V1 Okay, because the empty set is in V1, because V1 is equal to V0 union the power set of V0, and the power set of V0 is equal to X, such that X is a subset of V0, and the empty set is a subset of V0 because the empty set is a subset of all sets. Okay, now that I'm I apologize. I hope this proof is a little more clear than my earlier explanation. But still, if you are confused or anything, just leave a comment and I'll be happy to clarify. I might redo this video in the future too. So there's that. Okay. And now there's one case left to check because we've checked that this is true. This is also true. So all we have to ask is whether this last one is true. So our last question is this here set in V2? Well, for this set to be in V2, then is in V1 union the power set of V1, because that is just how things are defined, right? So for this to be true, um, we can just ask whether this set is in either of them. Now this looks like quite a big set, so I'll just ask the question of whether it is in here. So is it in here? That's the question. Now it is here if and only if this is a subset of V1, which is if and only if sorry, this is in V1 and this is in V1. This looks like an 8. Okay. And now this this would imply that is in V1, which is equal to V naught union the power set of V naught. And now this is obviously not true. But is this true? Well, this is in the power set of V naught if and only if um, this is a subset of V naught, which is if and only if this is inside V naught, but this is not true. So, after all our hard work, it turns out we haven't found the answer yet. But it's okay. We'll keep going. All right, all right. We would have to check technically that um, these are not in V1 either, but that check was done here, or rather, a stronger assertion was done here. So, if it's not in here, it's definitely not going to be in here. I encourage you to try it out on your own. For the sake of time, I will just keep going and try with V3. Okay, so now, same question. Is this set um, So is B, which is equal to this set right here, a subset of V3? Well, let's ask the question one by one again. So 1. All right, so B is a subset of V3 if and only if this is in V3 and this is in V3 and this is in V3. Okay, so let's go one by one. Again, so it's 2 non's in V3 if and only if the empty set is in either V2 or the power set of V2, which is if and only if, or rather, yeah. Okay, let's stop there and say, and the empty set is in the power set of V2 because power set of V2, if and only if empty set is a subset of V2, which is true. Fab. Okay. Cool. Now 2. Is this element in V3? Well, this is if and only if this set is in V2 or the power set of V2, which is if and only if, or rather, this is in the power set of V2, I claim, if and only if this is a subset of V2, and indeed, this is a subset of V2 because V2 is equal to V1 union the power set of V1 and let me just pull up an extra page over here. And sorry, I'd rather write it like this. If and only if the empty set is in V2 and indeed sorry, I keep getting confused. And indeed V2 because V2 is equal to V1 union the power set of V1 power set of V1 because the empty set is a subset of V1. Okay, cool. Fantastic. Now, for 3, once again, we have this set. Okay, now is this in V2? V3, sorry. Well, this is true. If and only if this is a subset of V3. Sorry, this is in V2 union power set of V2. Okay, and now note or observe that is in the power set of V2 because this is a subset of V2 because in V2, or rather, let's just break this off into two cases. A, 0 is in V2 because V2 is equal to V1 union the power set of V1, and the empty set is in the power set of V1 because the empty set is a subset of V1. Okay, so that's one. Now let's go for the second one. Okay. Now the set containing the empty set is in V2 because V2 again is equal to V1 union the power set of V1, and this is in the power set V1 because this right here is a subset of V1 because this is in V1 because V1 is equal to V naught union the power set of V naught, and the empty set is in the power set of V naught because the empty set is a subset of V naught, is a subset of all subsets. So, moral of the story, our overarching goal from the beginning, we've showed this is true, we showed this is true, and we showed this is true. So, what did we just show? Oh, sorry, my bad. I jumped over. Oh, we showed this is true. Ah, this is true, and this is true. Cool. So, we showed these things hold, and this B is a subset of powers of V3. So B is a subset of V3, and thus the rank of B is 3. Okay, cool. Now, I apologize for any confusion I might have caused. I got a little um, shaken by this problem. It's not too difficult. I think if you just rely on intuition, you can compute it pretty quickly. I just wanted to be as thorough as possible, and I kind of shot myself in the foot that way. Still, I hope this gave you at least some insight. At the end of the day, you should be doing these exercises on your own. Um, that's how you learn mathematics. It's not a spectator sport, unfortunately. But yeah, let me know if anything was confusing in the comments. Otherwise, I will see you in the next video.